Hi General Math students. In this video we're going to practice constructing some scatter plots and we're going to talk about correlation. You can see on the screen now that there's a scatter plot here and it's showing the relationship between increasing temperature and number of soft drink cans sold. So we would expect that in warmer temperatures people are more likely to buy cans of soft drink, and we can see that there does appear to be a correlation there, and we could even put a line or trend line to these points, and we can see that there appears to be a positive relationship or a positive correlation between temperature and number of cans sold. Now with the scatter plot, which is something that's probably familiar to you, a scatter plot, one thing to note is that we have an independent and a dependent variable. So in this case we would assume that the number of soft drink cans sold depends on the temperature, right? So our soft drink cans sold is our dependent variable and temperature is our independent variable. Now it's important that dependent variable goes on the y-axis and the independent variable goes on the x-axis, the horizontal axis. We've got to get that the right way round. Okay, so let's practice a scatter plot and then look at some stuff on correlation. So we're going to look at this one here, and in this we're examining the relationship between hours of study and a test result. So we would expect that the more you study, the better your score will be on a test. It doesn't always work that way. There are other factors, such as perhaps you studied really hard for a test, spent a lot of time studying, but you were late for school that day and you were late for class, so that stressed you out and it affected your test result. Or perhaps the test is on a subject that you know really well, so you just do no study, but you still do really well on the test. But in general, we would agree that more study leads to a better result. So let's plot the data on this scatter plot. Hours of study is the independent variable and test result is the dependent variable. So we're going to have test result on the y-axis. We'll put this up here, and that's as a percentage. So we label our axes and then hours of study on the x-axis. So you must label the axes. Now we're going to scale them. Okay, test result is out of 100. The biggest score is 95, which is close to 100. So I think if we go up to 100 on this scale, we'll be in good shape. So if we go up in tens, we can go 1, 2, 3, 4, 5, 50, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. You notice I'm not writing every single number on that scale, just 50 and 100. So it saves time and makes the graph a little neater and less cluttered. Okay, hours of study. The most that anyone did was 8 hours. So let's see, if we go up in ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hours. Now that is not bad because 10's a little bit higher than 8. So we're using most of the grid and we're covering the highest number of hours of study, which was 8 hours. Right, so I'm going to go ahead and plot this now. And this is something that's probably familiar to you. So here we've got the first point is 5 and 62. Okay, so that would be about here, just above 60. We don't need to be surgically precise with these because this grid is not all that highly accurate. So just in the general area is okay. 3 and 95. So go ahead and plot these data points. You might even want to just fast forward to the end of this video, plot the points and see if you've got, oh, sorry, not when I say the end of this video, the end of me doing this scatter plot, so that you can just do the scatter plot yourself and then see if you get the same data points as I do. I'll keep going though, I will persevere, do it as quickly as I can, but with maintaining a nice neat scatter plot and accurate as possible. Okay, 0 and 15, 7 and 60, nearly there. 7 and 68, 4 and 50 right there, and 3 and 30. Okay, there we go. So the scatter plot's done. We've done this bit. Now, what type of correlation do you think is involved? Question mark. Now, if I look at this, I can sort of see an upwards type trend. Perhaps I put a trend line sort of here, maybe, something like that. It does seem that there's a trend. It's not as obvious as, say, the soft drink cans versus, or the temperature versus soft drink cans trend. That those data points form more of a straight line, although neither is perfectly straight. But I just want to show you this page here. Hold on, where is it? Bear with me, here it is. Now this is in your book, this page. This is going to be important for us later in this example when we start to talk about correlation. But what we're thinking here is that the data points are a little scattered. They're certainly not lining up all nice and straight like this strong positive correlation. Maybe they're not quite as scattered as the weak positive. Maybe what we're looking at here is some moderate positive correlation. But it is tricky to tell just from by eye what the level of correlation is. In a moment, the calculator is going to give us a precise number for the level of correlation, which we will fit into that continuum we were just looking at. So I'm going to make a little guess here and say moderate positive correlation. So use your calculator to prepare a screen plot and find the correlation coefficient. So let's do it and see what the correlation level actually is. So here we are in the calculator. We want to go to this green button here. So let's go there. And we're going to enter that data into the calculator. So I'll just get this set up. You can get your calculator fired up and start entering this data. So the hours of study will go in list 1. So I'll put those in there. Enter that carefully. Make sure you get the numbers right because it will change your answers if you don't. Okay, that looks okay. Now, the test score goes in column 2, or in the table. Okay, so we've got put those in. So yeah, you can go ahead and do that now. Last couple. Okay, there we go. Right, so I've entered the data. So the first row goes in the first column in the calculator and the second row goes in the second column in the calculator. So let's get the screen plot and the correlation coefficient. We'll go back here. So first thing we need to do is we need to put some letters for the variables up the top. Doesn't really matter what you put here, just as long as you remember what it is. So here we've got hours of study, so I'm just going to put H for hours. And here we've got the score on the test, so I'll put S for score. All right. Now, we're going to go and get a screen plot. So we're going to say, okay, menu, beg your pardon, not menu, home. And we go to this pink button here. And now you're going to need to use the little pad in the middle of this thing here. It's a little tricky to use, but use that to drag this cursor across onto this area here. And I'm going to click there. And remember, H was on our scatter plot we drew by hand, H for hours. So I'm going to put the H down there, and then the score goes on the y-axis. Click on that. And there is our scatter plot. So we can compare that to the one we drew by hand. Try and get him over here. Okay, and we can see that we've got the same pattern there. It looks the same pretty well. So that's a good sign. Okay, So now let's go back to the calculator, and we're going to get the correlation coefficient now. So go back to the home screen, and we're going to go back to our spreadsheet. Okay, now I can see here I've come up on a different spreadsheet, so I'm going to go Control and Tab. Actually, now that I think of it, we could have just done this before. You could just go Control Tab across to that one back to the table. So we're going back to the table any old way you can, and you're going to go to Menu, Statistics, Stat Calculations, and we're going to choose a linear regression. Now this will give us our linear regression, the perfect line of best fit, but it will also give us the correlation coefficient. So H for hours is our X variable, S for score is our Y variable, so OK. Now if we go down, we can find here is our R value here. And it's 0.508. Okay, so our correlation coefficient, 0.508. Right, so where does that fit in terms of the level of correlation? So just shift this back a little bit. So in fact, our R value was just over 0.5. Just going to make a little note of that. So R, oops, a daisy, bear with me guys, sorry about that, just acting a bit funny. R equals 0.508 something else, right? So what level of correlation is that? If we look back at our continuum here, 0.508, so it is in the moderate to positive range. 0.508 is just above 0.5, so you can see that we're within that range of moderate positive correlation. Now in the next part of this question, we're asked to make a conclusion. We use these conclusions that are written here to do that. See this conclusion here? Because this is moderate positive correlation, we're going to write this conclusion, this sentence. But we need to replace the variables X and Y with the actual variables we used in this question. Now remember, the X variable this time was hours. So instead of X, we're going to refer to the number of hours of study. And the Y variable was the test score. So we're going to replace the Y variable with the variable, the test score. All right, so let's go back and write this conclusion. Now this might seem like it's tricky to remember these, but with some practice and just basically repetition, you will get good at remembering these sentences. Let me show you. I can write it right now. So there is a moderate positive correlation between the variables. So if that's the case, then there's only some evidence to show. So we say there is some evidence to show that the greater the level of hours of study, so see how I've replaced that X variable, the level of X, with the actual variable, which is the X variable, the hours of study, the greater the test score. And see how that is the Y variable. I've replaced that in the sentence. And that's how we do the conclusion. Okay, so quite a bit to go through there. Go ahead and look at the description for the video and try those questions so that you can get good at scatter plots and correlation.